right? Even though we're not doing a lot with what we call complex fractions, I want you to see kind of what negative exponents can do and how they can, another way they can be looked at. Negative exponents is not something we cover, but just want you to see kind of what can happen if they're in fractions. Right? So if I gave you a problem like this, you all should know that you should apply your rules of negative exponents, and they should switch places. And then from here you would simplify, and x to the 2 minus 3 is x to the negative 1, which means my leftover x is going to be in the denominator. This would be the same thing as if you wrote 2x's, divided it by 3x's, did cancellation, you'd have 1x left over in the denominator. Complex fractions are something that's in a similar form. They're also usually represented by this, but they do addition of these pieces. It gets really ugly, but I'm going to kind of give you an idea of what you would do if you saw it and were asked to do it in a complex fraction form. Again, I'm not going to test you on this, but it's something cool if you want to go ahead and try something that's a little harder. All right, so I'm going to take the same fraction that I have, and right at the beginning, I'm going to go ahead and make x to the negative 3 its own fraction. And I'm going to do the same with the negative 2. This, what you're seeing, is what we call a complex fraction. In this one, there's no addition attached to it. There's no adding in the top or adding in the bottom, which makes this the most simplest form of a complex fraction. What we would do is use what we know about fractions and division of fractions. Remember, when we divide fractions, we keep, change, flip. We're going to do the same thing here. We're going to keep the 1 over x to the 3rd power. We're going to change the division to multiplication. We're going to flip the second fraction over. When I multiply straight across, I still get my x squared over x cubed. My answer is still 1 over x. Okay. This is where this idea of negative exponents came from, is division of fractions. Now notice the second one here I did with it in a fraction took a little bit longer. You would not want to do this unless for some reason I had, let's say, x to the negative 3 plus x to the negative 2 over something similar. Okay? We're not doing any of those. So if you want to experiment with this and see if you get the same answer, it's just another tool in your toolbox. And I'll see you in the next video.